Over the past couple of days, we have been using what's called rectangular models to show the products, no, excuse me, the partial products using area models. Now, in our learning, you learned that in a rectangular model, you have width and you have length. And when you find the product of length and width, it tells you how much space is inside a closed figure. Now notice, I have represented this area inside of the figure. Now this skill is critical because we can use that same understanding to help us find products of when we are multiplying whole numbers that are large. For example, yesterday, we took that knowledge to say, how do we represent 4 times as many as 78 using the rectangular area models? We represented the width using 4, and then you broke apart or decomposed the value based upon its place. 7 tens, 8 ones. This lets you know how many parts are in your area model. This area is for tens, and this area is for ones. Now the length is 70 plus 8. But in this part, it's for 70. So we used our understanding, 4 times 70, and then 4 times 8. Now, this is huge. This is where you use your tools strategically, okay? This is where you can understand, well, you know what? 4 times 70, if I wanted to say repeat addition, it's the same as saying 70 plus 70 plus 70 plus 70. Or the tape diagram, which also says the same thing. 70 plus 70 plus 70 plus 70. But me personally, I prefer to use the most efficient strategy. If I know that I'm multiplying by tens, I look at 4 times 7, and I know that equals 28. And in the pattern, if I said 4 times 7 with a 0, my answer is going to be the same product with a 0. Now you're getting it. And that's why tens are so friendly. I could keep going. Well, it's 28, but I have 2 zeros. And if I said 4 times 7,000, well, it's still 28 with 3 zeros. So now it's 28, and it keeps on going because that's multiplying by tens. So let's circle back. In this first area, I have 4 times 70, or 70 plus 70 plus 70 plus 70, or 280. So in this area, I have my first partial product, 280. Now solve for tens. So now I need to solve for ones. So let's 4 times 8. Well, 4 times 8 is the same as saying 4 times as many as 8, which is 8 plus 8 plus 8 plus 8. And when I add up my sum, it's 32. But because we work on our math facts so we can be more efficient, 4 times 8 is 32. Our second partial product has been solved for. So hopefully now that you've noticed, and I'm going to mess this model up, just so you can understand, now this whole rectangle has now been solved for, just like if we were trying to find the area of this figure. And when I add them all together, now I know that this model is saying this, all this space inside for 4 times 78 is 78 times 4. And my first partial product is 32. Now, friends, this is where our standard algorithm addition comes in. We must line up our values according to place value. 32, and then 0 ones, 8 tens, 2 ones. 2 hundreds. I add them all together. 2 ones plus 0 ones is 2. 2 ones. It's important. Now, 3 tens plus 8 tens is how many tens? 11 tens. But 11 tens is 1 10 and 100, because 10 tens equals 100. That's why I transfer the 1 to the hundreds place. So now I have 100s plus 200s, which gives me 300. So 4 times 78 is equal to 300 and... Now that's where we were, but now this is where we're going. Take a moment to notice, and I want you to notice something. If I said 8 times as many as 248. Think about this. What am I saying? Think about it. Now that you thought about it, turn to a partner and tell me, what expression am I saying? Take 1 minute. Turn and talk to a partner. One, two, three, eyes on me.
1, 2, eyes on you.
Ha ha. Hopefully you all said, you know what, Mr. Hughes, I didn't get caught with your trick bag. I know 8 times as many as 248. If you was to express it, it would be 8 times 242. Now, whoa. You got to solve this. Now, hopefully you all are not panicking because there's a way that we can solve it. Now, if you want to, you can use your 3rd grade skill and you say, well, you know what? This is saying 8 times 242. Well, Mr. Hughes, I can say 242 plus 242 plus,
242.
yeah, plus,
242.
oh, wow, plus,
242.
well, that's 1, 2, 3, 4, 5 times.
242.
You know what? I'm already getting tired with this. Whew, gosh almighty. I'm tired of that. I could solve that way. Yeah, I could. But would it be an efficient way to solve? No. No. So mathematicians always look for the most efficient way. So let's use our skill and build on our skill. Let's use a rectangular area model. This time I'm going to make it nice and big. And in this time, I know this is 8 times 242. And I know I could place my 8 as the width. But if I wanted to break up 242, now I have hundreds, tens, and ones. 2 in the hundreds place is 200, because 2,000 would be, now notice, I'm going to use my tools just so we don't make a mistake. 200 is 2 100s. It's 2 100s. That's why it's 200. And I got tens, so I'm just going to go ahead and represent, just so we can know, my tens. Each one of this is 110. But how many tens is in the tens place? Now I'm confused. I heard 4, then I heard 40. Give me a thumbs up if you think it's 44s. Or 4010, excuse me. Or what about 4 tens? Get a thumbs. Yes, it is. That is 4 tens. So 4 tens is 10, 20, 30, and 40. Maybe that person thought 4 tens, they were just saying it's 40. So I'm just going to represent 40 on my area model. So I got 200 plus 40. Now in the ones place, this says 2 ones. I don't need to use that, but if you would like to use represent, now I got 2 ones. 200 plus 40 plus 2 is 242. Now, the whole point in the area model is to break it up so you can solve it easier. So let me use a different color. I'm gonna use my blue. Now, in the hundreds place, this is 8 times 200. There go that large number now. That is 208 times. Now, I'm just going to visually show you one copy of 200, two copies of 200, or 2 times 200. Notice, now what's my total for 2 times 200? 100. Well, let's go. 3 times 200 gives me what? 600. 4 times 200.
800.
You're getting the gist. You're getting the gist. 5 times 200. 1,000. Now, I don't have enough space, but I do know this. If I use my other strategy of multiplying tens, I know that 8 times 2 is 16. And I know that I have 2 zeros, so I'm going to have 2 zeros in my answer. So 8 times 200 is 1,600. First partial product, solved for. Now, 8 times 4 tens, or 40. 8 times 4. Now, if you don't know what 8 times 4 is, you can simply say 40 8 times. 40. Do I want to really do this? 40 plus 40 plus 40 plus 40 plus 40 plus 40 plus 40. I tell you what, that's 1, 2, 3, 4, 5, 6, 7, 8 times. That's a lot of adding, right? Yeah. I don't think I want to use that strategy, but if I have to, I would. But me personally, I know that 8 times 4 is 32. So 8 times 40 would be 320. Second partial product done. Now we're in the ones place. Oh, I got 8 times 2. Oof, this partial products, it's a lot of work. So what's 8 times as many as 2?
10.
Now someone said 10. Help that make sense. 8 times as many as 2. So if you think 10, then agree with me. Well, let's find out if it's true. 8 times as many as 2 is 2 plus 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5, 6, 7, 8. Well, 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. Now that person has already been disproved. Because I still got some 2's to add. So it can't be 10. Plus 2 more is
12.
Plus 2 more is
14.
Plus 2 more is
16.
Yes, 16. So now we have 1,600 as one partial product, 320 as the second partial product, and 16 as our third partial product. But we're not done. We want to put all of them together so we can now find the total area. 242 times 8. Our first partial product was 16. Second partial product was 320. And our third partial product was 1,600. And when we add all of it together, 6 ones plus 0 ones plus 0 ones is 6. 6 ones. 1 10 plus 2 10s plus 0 10s is 3 10s. 300s plus 600s is 900s. And then we don't have anything to add here, so it's still 1,000. 8 times 242 is 1,936.